With ionic and covalent bonds, there are certain names that must be used in order to identify a certain compound. In order to advance in the world of chemistry, you have to know how to do these things. Right here, we have one method of naming one type of these bonds, and that is a representative element bond. These elements are located on the left and right sides of the periodic table. In order to know how to name these, we will use different examples, such as magnesium nitride. In order to name the formula, the formula must be made. To do this, find the charge on the periodic table for each element and switch the numbers. In this case, magnesium has a charge of positive 2, and nitrogen has a charge of positive 3. You then take the element symbols and put them in order of cation first, magnesium, and nitrogen, anion. Magnesium has a charge of positive 2, and nitrogen has a charge of negative 3. So the numbers are then switched because those are the certain amount of atoms that are used for it. By naming them, you would have to say the first element symbol, or the cation, magnesium, normally, and then the anion, second, nitrogen, with the "ide" at the end, making it magnesium nitride, and the chemical formula of Mg3N2. With polyatomic ions, it is slightly different. A polyatomic ion is a group of atoms that has its own charge, but the process for naming them is quite similar to regular ions. To do this, it's the same as normal. Let's have hydroxide with a -1 charge, and magnesium, again, with a +2 charge. You would switch the numbers as normal, but hydroxide will have a number and a group of atoms, so we have to differentiate the two and put a parentheses. The naming is quite similar as well, with the cation first, but the name of the anion is different, such as nitrate, so those will stay the same as well, with magnesium hydroxide, with the formula being MgOH2. Transition elements are the same as well, with just slight modifications. Transition elements are located in the middle of the periodic table and have different oxidation states, which give it certain charges. For example, iron has a charge of 3+, and chlorine has a charge of 1-. Then you take the numbers and switch them, and once more you get FeCl3, but now we have to name it. By using the charge of the cation iron, we can use the Roman numeral to put it in between the two, and with the same naming as the other types to get iron chloride. Covalent bonds are much different than ionic. While ionic bonds have metal and nonmetal, covalent bonds have two nonmetals which share their electrons. When they do, they have to be named as well. Let's use dinitrogen trioxide. In order to name them, you must know the chemical formula, which is N2O3. This is done because of the amount of elements needed to fill up the outer orbital of electrons for both atoms. Once you find that, the naming is easy. For the second element, put an IDE at the end like you always would and name it like normal. Except there are prefixes to note that you use for naming them, which are mono, di, tri, penta, hexa, hepta, octa, nona, deca. For this case, we will use di, which means 2, right here, and tri, which means 3, right here. So the name would be dinitrogen trioxide.